Hey mathematicians, let's do our homework. Oops, I went too far. This is tomorrow's homework. Here's our homework. Okay. Oops. It does not matter to me which side you start on. I'm going to start on the adding and subtracting side. So both sides are inequalities. That means I should not see any equal signs when you give me your homework tomorrow. Let's start with number 1. So I'm going to start trying to isolate x. These are the two sides of my inequality. I have the side with x plus 3 and I have the side with 19. Isolating means I want x to be alone, like it's in isolation. So we got to get rid of that plus 3. To get rid of it, we are going to do the opposite of it, the inverse of it. And that is a minus 3. We do this because plus 3 minus 3 cancels out and it makes 0. And x plus 0 is just plain old x. But we have to stay balanced. We can't take away 3 from one side and not from the other side. So I'm going to take away 3 from 19 as well. 19 minus 3 is 16. And you are going to keep that exact same greater than symbol. That's your solution. X is greater than 16. You don't have to graph it, but if you were going to graph it, whoops, there go the lights again. That would be an open circle because there's no or equal to line. So when you see an adding symbol, you are going to subtract. When you see a subtraction symbol, you're going to do the inverse of that. The opposite of minus 4 is plus 4. Stay balanced, do it to both sides. You should end up with y. This one is a less than symbol, and 4 plus 4 makes 8. Y is less than 8. Again, this one would be an open circle because there's no or equal to line. And your arrow would be going on the numbers that are less than 8. So 7, 6 is trending towards the left because that is the less than side. You're going to solve all of these. If you were to graph it, this one would be a closed circle because it does have that or equal to line. Flipping the page, because all these are adding and subtracting, we're going to some multiplying and dividing ones. Ooh, right there. I see that fraction bar, and I know that that means division. So this is some number divided by 4 is going to be bigger than 15. Instead of trying to be like, well, is 1 divided by 4 bigger than 15? Is 10 divided by 4 bigger than 15? We isolate our x so that it will just tell us, oh, hey, any number bigger than, greater than this one. And to do that, we're going to do the opposite of dividing, which is multiplying. I use my parentheses. And the same number that's on the x side. This is a 4. I'm not using 15 because it's not on the same side as x. Both sides are getting multiplied times 4. These are going to cancel out to 1x, which I can just write as x. 15 times 4 is 60. Keep your greater than symbol. That's so much easier than trying to think of numbers that when you divide them by 4 are greater than 15. Anything bigger than 60 would make that a true statement. You could not put a closed circle here. There's no or equal to, so 60 is not greater than 60, but anything bigger than that would satisfy or make it true. What are they when they're smushed? They're being multiplied. So to undo multiplication, you are going to divide. I use the fraction bar division symbol. We're dividing by the same number that's with y, not 15. We're dividing by 5. 5 divided by 5 is 1, so 5y divided by 5 is 1y, which I'm just going to write as a y. 15 divided by 5 is 3. Do not change the order of the y and the 3. They have to be on the same sides they started on. And keep your greater than or equal to symbol. So that's what you're doing on the back page. If they're smushed, it means they're being multiplied, so you have to undo it by dividing. If they're being divided, either with a fraction bar or with a regular division symbol down here, you're going to do the opposite of dividing, which is multiplying.